Alright, so today our learning target is to determine if two shapes are similar. If you are in my class, this would be a good idea to copy down the learning target and to follow along in your notebook. So the first thing we need to do is to determine what similar figures are. Let's add this vocabulary word to our notebook. Again, my class, you know to put a box around the vocabulary word so that we know it's important, so it's easy to come back to that later. So we can determine and we can define similar figures as two shapes that are the exact same shape but are different sizes. So if you take a look down at the two shapes that I have below, we have a small right triangle and then we have that same right triangle that's just enlarged. So we're going to go through a few examples, and as we do, make sure that you are following along, again copying those down into your notebook. So our first example, we have figure 1, which is a triangle with the side lengths 3, 4, and 5, and figure 2 with the side lengths 6, 8, and 10. Now what I'm going to do is I'm going to do some color coding so that I can easily determine which side lengths are corresponding. So I'm going to highlight side length 3 and side length 6. Those two are corresponding sides. Side length 5 on figure 1 and side length 10 on figure 2. And side length 4 on figure 1 and side length 8 on figure 2. Then we are going to always compare our side lengths, figure 1 on top and figure 2 on the bottom, and we're trying to figure out the ratio to get from figure 1 to figure 2. So that's going to look something like this. I'm going to set it up figure 1 on top, so that's that 3, and I'm going to go corresponding side lengths, so that's 3 to 6. So I'm going to go 3 over 6. And I'm going to use my giant 1 to figure out, is there a number that goes into both 3 and 6 evenly? So looking over there, I noticed that 3 goes into both 3 and 6. So I'm going to put 3 inside my giant 1. 3 divided by 3 is 1. 6 divided by 3 is 2. So my ratio is 1 to 2. Now I'm going to go check my second set of side lengths. I'm going to use blue this time, and I'm going to be comparing 5 to 10. So again, we're talking figure 1 to figure 2. So 5 goes on top, 10 on the bottom. And I'm trying to figure out what number goes into both 5 and 10 evenly. I'm going to put that number inside my giant 1, and I know that 5 goes into both 5 and 10 evenly. 5 divided by 5 is 1. 10 divided by 5 is 2. So again, I have a ratio of 1 to 2. And I'm going to do that for those last side lengths as well. We have 4 over 8. I'm dividing to try and figure out which number goes into both 4 and 8. And I know that 4 goes into both 4 and 8. 4 divided by 4 is 1. 8 divided by 4 is 2. So now I'm going to look and compare all three ratios that I came up with. And all three of them, in this case, are 1 over 2 or 1 to 2. So this is a similar figure. Alright, so example 2, we're going from a bigger triangle now to a smaller triangle. So we're going to do that exact same thing that we just did. I'm going to highlight my corresponding sides. I have 9 and 3, 15 and 5, and 12 and 4. So I'm going to do that same thing. I'm trying to find my ratio. I'm going figure 1 to figure 2. So starting out, We have 9 to 3, so 9 in figure 1. My corresponding side is 3 in figure 2. Again, I'm figuring out what number goes into both 9 and 3. I know that 3 goes into both 9 and 3 evenly, so 3 is going inside my giant 1. 9 divided by 3 is 3, and 3 divided by 3 is 1. Now we're going to go ahead and check that second side length. We have 15 and 5. So 15 goes on top, 5 on the bottom. I'm going to set up my giant 1. What number goes into both 15 and 5? That would be 5. 15 divided by 5 is 3. 5 divided by 5 is 1. So there's that one. We again have a 3 to 1 ratio. And then let's do our last side length, 12, and the corresponding side, 4. Dividing again, which number goes into both 12 and 4 evenly? That's going to be 4. 12 divided by 4 is 3. And 1. So then looking again, we have 3 to 1 for all 3 corresponding sides. So this is a similar figure. Example number 3, I'm going to do that same thing, highlighting my corresponding sides. It's important to make sure that you are comparing corresponding sides every time. All right, so there are my corresponding sides. I'm going to set this up exactly the same, starting with the 3 and the 15. All right, using my giant 1 to figure out what number is divisible. That's going to be 3. 3 divided by 3 is 1. 15 divided by 3 is 5. Next set of side lengths, I have 5 and 20, figure 1 to figure 2. Figure 1's on top. I need to figure out what number goes inside my giant 1. I know both numbers are divisible by 5, so 5 is going inside my giant 1. 5 divided by 5 is 1. 20 divided by 5 is 4. And my last set of side lengths, I have 4 and 16. And inside my giant 1, I know both numbers are divisible by 4. 4 divided by 4 is 1. 16 divided by 4 is 4. So now I'm looking and I'm going to compare these 3 ratios that I got. I have a 1 to 5, a 1 to 4, and a 1 to 4. So all 3 side lengths did not have the same ratio, so this is not a similar figure. Had I done these 2 first, the green and the blue side lengths first, I might have thought that it was a similar figure, so it's important that I don't stop there. Now, in your homework and in the classwork that you're going to be working on today, there's going to be some examples where you need to go from figure A to figure B using the ratio that they give you. So you're going to use the ratio to find those side lengths of figure B. So we're going to go through how to do that. Again, I'm going to use my highlighter to show the corresponding sides and where they go. So that 3 is going to correspond to that side length, the 5 to the one over there. And you're going to be doing this on Notability, so it might be a good idea for you to use color if that helps you. So now it says that the ratios from figure A to figure B is written as 1 to 4, or 1 to 4, or 1 to 4. Those are just 3 different ways of writing the same thing. So we're going to go ahead and actually, we'll do this first. We're going to start by writing down our side lengths. I'm going to leave some room so that I have some room to do the work. Now since it's getting bigger, we're actually going to be multiplying here. So 1 to 4, the 4 is telling us that we're going to multiply by 4. So I'm going to multiply each of these numbers. Make that a little neater. Multiply each of those numbers by 4. And I'm going to use my highlighter again. We have the 6, and that's the number that's going to be in my missing side. The green was the 2, so that's going to be that one. This is just telling me where I need to put these numbers when I'm done. So back we go. 3 times 4 is 12. 6 times 4 is 24. 5 times 4 is 20. And 2 times 4 is 8. So since I've color-coded, I already know where they go. My 12 is going to go with the pink or purple, whichever color. The 20 goes with the blue. The 8 goes with the green. And the 24 goes with the yellow. So there are all my missing side lengths. My last example, example 5, we're going from a bigger figure to a smaller figure. So it says that the ratio is 3 to 1. There again are my 3 different ways. So I'm going to set it up that exact same way. I'm going to use my highlighter again. I'm just going to set this up all at once. All right. Now since we're getting smaller, this time we're going to be dividing. So I have 18 and my ratio says 3 to 1, so I'm going to divide by 3 to get my answer. 18 divided by 3 is 6. Going on to the blue, we have 15. Again, dividing by 3. And we get 5. 24 divided by 3. And we get 8. And 12 divided by 3. And we get 4. So there it's telling me exactly where my side lengths need to go. 5 with the blue and 4 with the yellow. So there we go. Feel free to watch this video again as you're going through today's classwork and tonight's homework. You can always come back and check these out again.